Going to be working today on creating a throwing game, and this is going to be just the base code that I want you guys to use for creating your throw game for your next assignment. I'd like you to make something more than just this ball, so kind of take this concept and then elaborate more on it, but we're going to go through this code will give you the base for the next program that you're going to be doing. So the first thing that I want you to do is I want you to go to our website, our Moodle site, and from last week I would like for you to find the ball class that we were working with when we were doing our hit detection. And I just want you to download this ball class here. And then we're going to go ahead and we're going to open that up in Flash. When we look at this ball class, I just want to go through a couple of items in the class. What you'll notice is that there's some variables that are declared at the top. There's a variable called the radius. There's a variable called color. There's a variable called Vx and a variable called Vy. When these variables are declared as a public variable, what that means is that they can also be looked at as custom properties to this class that's been created. So in the same way that when we're talking to an instance and we're saying, okay, we want the x value, the .x value, the horizontal position to be a particular number, or we want the rotation of a particular item to be numbered. We can we can look at these as custom properties for this class, so that when we bring on a ball instance in another class, we can refer to the radius and the Vx and be able to change the values that are associated with that instance. You'll see that this class is passing through two arguments. It's passing through a radius number and it's passing through a color number. And the local variables here that are created then get changed out for their class variables so that they can be used in this init function, which just simply draws the circle. Okay, so let's go ahead and start a brand new class for creating our throw game. So File New and ActionScript 3 class, and I'm just going to go ahead and I'll call this Throw Me, and I'm using the 5.0, that's why it doesn't have that automatic box that you guys will be seeing. Oh, and so of course we're going to start at the top, and this is going to extend the sprite class like we've done a million times before. Let's do our import. Flash display sprite. Okay, so we're all set up here. And let's go ahead and let's create an init function for this class. We've done this a couple times before. This is going to be a slightly longer piece of code. So let's go ahead and let's keep our constructor nice and thin. We're going to create an init function, which is just going to be a function that sets the stage. We're going to be setting the stage with our init function. Okay, so let's go ahead and create our init function now. So how do we write this? I know that you're all saying, private function init. Now, what do we put in these parentheses? Nothing. This is not associated with an event listener, so it's just a regular old function. And we're going to do void for the return value. And now we can go ahead and we can start setting our stage. And what we want to do is we want to bring one of those ball instances, we want to bring one of the ball class into our throw game. So what we want to do is we need to declare a variable for our ball, and we need this variable to be available through the whole class. It needs to be able to be accessed no matter where we are in the class. So how do we want to, where do we want to declare our variable? I know you are all saying that we need to declare this as a class variable up here at the top. And this can be a private variable. We're not going to be referencing it from another class. And we will call this, how about my ball? Why not? And this will be a ball class. Okay, now that we have declared our variable at the top for the ball, now we can go ahead and instantiate our instance of the ball. So we'll go ahead and we'll do my ball just like we've always been doing, equals, and now what are we going to be putting? Yes, new ball. And now we'll go ahead and we'll pass through how large we want the ball, a radius is going to be passed through. And so let's say 40, why not? And we can pass a color through if we wish as well. Why don't we pass through blue, why not? 1, 2, 3, 4, FF, that will do it, yeah. Okay. And now we need to add it to the stage. Add child, and that will be my ball. And now we need to place the ball on our stage. Give it an X and Y position, unless we want it up in the upper right corner, and we don't really want it to really start over there. So let's go ahead and set a horizontal position, and we'll just do the stage. That's stage width divided by 2, just kind of center it up. And we'll do the same thing for the height, yeah. Stage height divided by 2. Okay, so now we have our ball on the stage. Now what we want to do, the first thing that we're going to actually be doing is we're just going to be setting up the bounce of the ball. We're going to make our ball bounce. Okay, and in order to create a bouncing ball, of course that's animated. So how do we create animation? Well, I know you're all saying, well, we need an event listener. And we do. So we're going to add an event listener. And I know you all are saying that we need an enter frame event listener. And that is true. We do need an enter frame event listener. So let's have it point to a function called move ball. How about? We can call it whatever we want, but why not, right? Okay. So let's create our new private function called moveBall. So we're going to be just doing a private function as we always do. MoveBall. And what are we putting between the opening and closing parentheses? We're passing through an event, because this is based on an event listener. So we get our E colon. event, and we will not be returning a new value, so it's void. And now we are going to be moving the ball along its x and y axis. Now if you remember from when we were working with the ship, what we were doing is we created a velocity speed, and then we set the x and y of the ball were moving based on what that velocity speed was. So we're going to go ahead and we're going to create a new variable up the top, a private variable called vx, where we can store our velocity for the x value and create a private variable called vy, where we can store the value of our velocity for the y-axis. Once we create these variables, we can also, let's go ahead and set them to 0 for initially. And then we're going to be making some amendments. So the very first thing, whenever we want to move an object, we're just going to go ahead and talk to, down here in our move ball function, we'll go ahead and talk to the ball, my ball, the x position, and we'll just add to its current position whatever the value of the x is. And we'll do the same thing for my ball along the y-axis. Add to its current position the value of vy. Okay, so right now, if we ran this, let's go ahead and save this out. Save, and make sure that it's called throw me. Match the class and the constructor, the exact same name. And let's just throw that into a compiler. Throw me. And I'm just going to save that back into my saved folder, of course. And so when we run this so far, oh, let's see, we've got an error here. Let's see what our error is. A type not found on number 24. Okay. Oh, what did I not import? What did I forget to import? Why, I know what you're saying. You're saying, Mayor, you forgot the event listener imports that you have to do. And you're right. So import flash.events.event. We have a little background music going on, sorry.
Sorry.
So now we should be able to run that. And so we have the ball. The ball is not moving. And can you guess why? Why? That is because our Vx and our Vy are set to 0, which means that it's adding 0 to the current value. Okay, so what we need to do is we need to set an initial Vx and Vy value for our ball. And so what we're going to do is when we initialize our class with our init function, we're going to bring a ball onto the stage, and then we're going to also set an initial Vx value and a Vy. So we'll start with the Vx. We'll just say that Vx wants to equal, and random numbers are always very fun to use, so we'll do a math random here. We'll do a math random, and then of course we need to times it by a value, and we're just going to have it go a little bit. We're going to have it go either a little bit to the right or a little bit to the left. So I'm just going to times it by, let's say, 10. Now, we want that value to possibly be moving in the negative direction or in the positive direction. So what I'm going to say is that we're going to subtract from that another 5. So what will happen is that a number will be calculated and times by the 10. So let's just say that that number ends up being 2. And if we subtract 5 from it, that means that it will end up going off to the left and a negative 1 value every time it enters the frame. So we can end up going either right or left, and that's good. Okay, now we're going to set the Vy as well, and for this one we just want to set it at a straight -7 so that we can automatically have them all moving at a -7 pixels, that's in the upward motion, right away as soon as it starts. So that way what's going to happen is that it's going to be floating up, and then what we're going to do in a minute is we're going to apply gravity to this ball to start bringing it back down to Earth. So let's take a look at this. Let's save it and let's run our program. And so as we can see, there it goes floating away. And every time you run it, it's potentially going one way or the other way. It's random, we don't know which way. Okay, so now we have the initial values set. So now what we want to do is we want to modify these initial values by applying some gravity. So the first thing that we're going to do is we're going to go over here and we're going to create a new private variable called gravity. And what we're going to do is we are going to set our gravity to equal, let's say, 0.2, how about? And we can, add more or less to the gravity as we go. But we are, gravity is, you'll notice that that's a positive number. And so what's going to happen is that what we're going to do is we're going to apply the gravity to the Vy, the velocity y, and it's going to slowly chip away at the value of our velocity y. So down here in our move ball, we're going to redefine Vy. We're going to say add to it gravity. So take whatever value it's currently at and add gravity to it, and then it's going to be applying it to the y-axis of the ball. And so every time through, the Vy will actually be recalculated. And as you can see, when we run this, is that it goes up, but slowly it gets chipped away. 0.2 gets taken away, 0.2, 0.2, 0.2, and that value slowly gets eaten away. And let's just do a quick trace and you can watch this happen. So we're just going to trace Vy, and we'll run this. And you can see its values up here in the window, in the output window. You can see it started off as -7, then went to -6.8, 6.6. So clearly not moving. as quickly up, slowly slowing down, and then finally gravity completely takes over and it comes to a rest and then starts moving in the opposite direction, starts falling. Okay, so now let's go ahead and let's create some boundaries, because as you can see, the ball falls off the stage and we never see it again. And that's not what we want to have happen. What we want to have happen is we want the ball to hit the edge of the stage and then go ahead and bounce back in the opposite direction. Okay, so now let's go ahead and set up our boundaries. And we've done boundaries before with our ship, so we're just going to be the same concept. And what we're going to do is we're just going to start with detecting. What we want to do is we want to see whether or not the ball is passing the bottom. But in this case, we don't really want to see if the ball is really going past the bottom. We don't really want it to go past the bottom. We want it to basically, if the edge of the ball hits the bottom, then we want it to move in the opposite direction. So what we're going to do is, of course, we need an if statement. And what we want to do is we want to look at my ball. I'll look at the y value. And then, what we've used before is whether or not it's greater than, cursor jumped here, whether or not it's greater than the stage height for the bottom. And we said, what do we want it to do? Okay, now, like I said, we don't necessarily want this to be exactly the Y position, because remember, for the ball, the registration point is in the middle. And so what we want it to do is we want to make sure that as the ball is falling, it's that outer edge that gets detected first. So what we're going to do is we're going to say, look at the Y position, and then what we're going to do is we're going to add to it my ball. Now we're going to use one of those custom properties from the ball called the radius. And let me spell that correctly. Remember that this is a custom property that's in ball, and this value has been defined by whatever value was passed through. So what's going to happen is that Flash is going to look at the ball instance and is going to read whatever value is stored as whatever value is given to the radius here in the ball. It's going to read that value and then apply it here. So as the ball is falling, it's looking at it first looks at the middle registration point, and then it adds to it to look on the outer edge of the radius. And as it's falling, it's really looking at that outer edge of the radius to see whether or not that one is past the stage height. Now, if it is, what we want to do is we want to redefine the y. And what we want to do is we want to times it by a value, and we want to times it by a -1. And the reason we are doing that is because, remember, you always want to move it in the when you times our value, it's going to by the -1, it just moves it in the opposite direction. So so if let's say that it's going to hit the bottom, right? So it's going to be going in a positive direction. So we, if we were looking at some of those numbers that it was at on that output, you'll notice that it was like a positive 10.2. It was like positive 10.2, probably at the bottom. Well, when it hits the bottom, it will, and it runs and recalculates the Vy to be 10.2 times a minus 1. Well, then all of a sudden it's going to be moving by a minus 10.2 value every frame. So of course it's going to be going back up very quickly. Yeah. So okay, so now we're going to do the same thing for the top using our else if, like we did for our ship. And of course, though, this time we'll be looking at my ball.y minus my ball's radius. My ball.the radius. And you'll notice that here in Flash it even prompts you. It understands that that ball class has a custom property of radius, and so it'll give you that prompt. And in this case, of course, it's going to be less than 0. 0 is always the top of the stage. And we're going to also just tell it to recalculate Vy times equals minus 1. And of course this works too, because if it is moving in a negative direction and it hits the top, a minus times a minus always equals a positive. So it'll start going in a positive direction, which of course means that it's going to be going down. Okay. Now we're using a lot of the same number here. So let's make this a little bit more efficient. Let's actually create a variable so that if we want to change the value of this bounce, we can very easily. So here at the top, let's go ahead and create a private variable, and we'll call it the bounce. And we'll start by having it equal to minus 1. And now, of course, we just want to go ahead and change out in our code where it says minus 1. We're just going to change that to be the bounce. Okay, so now when we run this, there it goes up, comes back down, boom, goes back up, goes back down, boom. Oh no, but look at, it's running away. It's going off the screen. Okay, let's fix this. So we have our boundaries set up for the top and the bottom. I'm going to just comment out my trace. I'm just going to comment out this trace. And let's do another set of if statements for our x value as well. So now we're going to be looking at the ball x, and once again, so let's first look at the right side. So what we want to do is we want to make sure that we're detecting the far right edge of the ball. So we look at the x position and then we add on it to it. The ball's radius, so my ball dot the radius again. And we're looking to see if that is greater than the right side of the stage, which we can use our stage dot stage width in this case for that value. Okay, so if it is beyond stage width, what do we want it to do? In this case, we're not affecting the Vy, we are affecting the Vx, yes? Because it's our velocity along the x-axis that needs to change. So we're going to do the exact same thing. We're just going to times it whatever the current value is, by our variable called the bounce. And this is where it's very nice. See, now we're using it like, we're going to end up using it 4 times, and it'll be much easier to work with when we have it all in a variable. Okay, and now let's do an else if for the left side. Ball dot x minus, of course, this time ball dot the radius, and this time we're looking to see if it's less than 0, which is of course for the left side. And we're going to be doing the exact same thing. Vx times equals the bounce. Okay, so now we have our boundaries set up. So now when we run this, when the ball goes, and this time it happened to be off. Oh, look at it. That was a good shot. It went all the way over there. Boom. And it's now the only issue that we have here is that it's just going to keep going pretty much in the same pattern. We do have gravity that is eating away a little bit at this. We need to add some other physical forces to this, and the main thing is, and it's very easy, is that when an object hits another object, when the ball bounces off of the floor, it has this inertia and it has this energy to it. But when the ball or an object hits another object, it has some of its energy taken away when it hits that object. Some of the energy gets absorbed into the floor or whatever it's hitting. So it's not as strong as it was when it initially was, whatever velocity it was going at, it's not going to have the same velocity. It's going to be cut back a little bit. So instead of making our bounce at a -1, we're just going to roll that back in the same way that we did for the friction, is that we're going to actually times this by a percentage instead, a decimal point. Basically saying, okay, I want this to be 80% as strong as it was. So we're taking about 20% of its energy out. And you can play around with that value. You can take out less, you can take out more. It's up to you. But we're going to change that bounce so that it actually has some energy taken out of it when it bounces. And it kind of got caught in a little loop there. Let's make sure that it may have gotten caught. I think we have a little issue right here. It's getting caught on the bottom. Okay, so let's take a look. Okay, so the issue at hand is that we need to, what's happening is that our ball is hitting the bottom of the screen or one of these various screens, and the reality is that it's actually coming down way past the bottom. It's not just hitting the bottom, and so even when the bounce comes back, it can't get past this if statement, and so it gets sucked down into it. So what we want to do is, before we actually reset the Vy, what we want to do is we want to just make sure that the ball is starting essentially at the edge of the stage, which if it's at the edge of the stage, that means that it's not greater than the stage height. It's going to start right at the edge and then go ahead and go back flying up. Okay, so we're going to say, first of all, we're just going to say my ball.y, go ahead and set that to the stage width, and then subtract from it the width of the radius. So we're going to take away just the value of the radius. So it places it just over, so that way it is not greater than that stage, stage height. Sorry, that was we were doing on the bottom, the stage height. And we're just going to subtract, still though, the radius, so that it moves it up, and it won't be greater than the stage height. So that way when we do the bounce, and it runs back through the frame, it won't get caught in here again. So we're going to do the same thing over here. I'm going to reset, make sure, just hard set the Y value to be, now in this case, all we really need to do is set it to the radius of the ball. Remember, that's a positive value. We'll just say my ball dot the radius. It's going to move it down. Oops. Gotta get a dot in there. Let me get, and let me spell that correct. Okay. So that, the radius would be like 40, so it's going to like set it at, pixel 40. And which will bring it down. It definitely will not be less than 0, and it won't get caught anymore. And so it will be able to do the VY and recalculate that bounce and keep going. Now we want to also do that down here for our if-else statements for the X value as well. So my ball dot X. Hard set it to be the stage width, and then we'll subtract my ball dot the radius, and we'll go ahead and reset my ball X to be just my ball dot the radius. Bring that down, or in this case, and it should then clear that so that it won't get caught in the less than loop. Okay, so now let's run this. Let's see where we're at. Here we go. There, it's flying. Boom, boom. And it's going yum, and it's going slowly slow down, and slowly getting eaten away, and it'll just kind of roll and roll and roll and roll, and it will slowly, as it hits against these sides, come to a stop. Okay, so now we've got the bounce done, and now we need to do the throwing part.